Okay, all right. All right, so it's my pleasure to introduce Sofia Franco. Sofia is a teaching assistant professor in economics. And she is a transportation / urban economist who has done lots of research on parking. So I think that Sofia is probably one of the top 5 parking experts in the economics business. She has a PhD from UC Santa Barbara. She's taught at various places in Southern California, including Riverside, Pomona, and we were fortunate enough to hire her a number of years ago in our teaching professor line. So today she's going to talk about parking.
Yes.
Anyway, so have fun.
Thank you. Okay, so thank you so much for having me here to talk about my parking research. So the paper that I'm going to be presenting today is joint work with Bowman Cutter from Pomona College and Skylar Lewis. He was a former student from Pomona. He's now working consulting. So this is our paper, and what this paper is going to be doing is going to basically examine the regulatory costs associated with a very specific parking policy, which is minimum parking requirements. And the goal here is not only to measure the shadow cost of the regulation, but it's also to understand how this cost, the shadow cost, actually varies over space. And we're going to do an application with data from Los Angeles County. Okay, so I would like to start first with the motivation. Why are we working on this topic? And I think it's we know that land use regulations, like for example, floor area ratios, height limits, inclusionary zoning, and also minimum parking requirements are pretty much like very common throughout the world. For the most part, whenever regulators impose these regulations, they have all the best intentions, right? A lot of them, they aim to protect either health or preserve amenities, or for example, to mitigate negative externalities, like for example, traffic congestion. The problem is that some of the critics of these land use policies, what they say is that even though they are well intended, a lot of these local regulations oftentimes are too stringent, so they're too restrictive. Or in some cases, like in the case of parking regulations, in particular minimum parking requirements, these regulations are actually either outdated and or completely unscientific, in the sense where they establish these minimum standards without actually taking into account the local conditions, like demand and supply, to say in a very simple way. And the implications of this is that if we have these land use regulations being actually binding, what happens is that we're going to be forcing developers to do something that they otherwise would not be doing if the market was unregulated. In particular, for example, we can force them to actually allocate more land to a particular use. For example, in the case of minimum parking requires too much land allocated for parking. And also we may force them not to actually attain the optimal building height, so the optimal capital to land ratio. So as you can understand, this is going to have implications right throughout the whole urban area, in particular to land and house prices. Okay. So one of the things that we can think about is that the cost of these regulations can be thought as a function of the land value. And if we think like that, then we know that, or at least we expect that binding land use regulations are likely to make actually development in areas that are considered to be high value areas, so areas where prices are quite high, right, actually more expensive. And I think this is kind of intuitive, right? And on top of this, if we think about that, land prices are not homogeneous across space, because land prices are like house prices, right? They observe everything that we see locally. So, for example, we know that local amenities or any particularities of the geography are all capitalized, right, in land and house prices. So it is to be expected that these prices actually vary over space. And if this is true, then we know that this variability that we observe in land prices can actually transform a policy that is actually uniform over space on a tax that is related to the land value, right? And this obviously will have implications on the marginal cost or the shadow price of a particular policy. We should not expect, right, the shadow cost of a policy to be uniform across space. So this is basically our motivation. So what we try to do here is, okay, we get it. So let's try to measure the shadow cost. And in particular, let's find a gradient over space for the shadow cost. And what we do two things in the paper. The first one is that we examine how the shadow cost gradient of a particular land use regulation, and that land use regulation is going to be minimum parking requirement for commercial real estate. So we're going to be working with office buildings, actually varies over space across adjacent metropolitan areas. And then second, we're going to examine whether the shadow cost is actually large relative to building costs. And the reason why this is kind of interesting to assess is because one of the main critics of or criticisms of minimum parking requirements is that because they're so stringent and so demanding, right, they tend to increase the cost of development, right? So we would like to have an idea by how much does the compliance with minimum parking requirement affects construction costs, which in turn we know that will be translated into higher real estate prices.
As a question, so what if there were no minimum parking requirements? What would developers do? Would they provide no parking?
No.
So in other words, what would the unregulated world look like?
No, they would provide parking, but the optimal amount that they would provide would not be the amount that you're forced to provide because of the regulation.
Would they provide too little? I guess, you know, is there some argument that says that maybe parking is underprovided by the free market?
Yes, there is also that argument because what they say is the reason why we need the minimum, one of the reasons why we need the minimum parking requirement is because the private developers do not take into account all the externalities associated with the parking that they provide. So,
like what?
Like, for example, traffic congestion and so forth. So
Parking congestion on the street.
yes, yes, cruising for parking. Let's put it this way. So, because of that, because parking is being determinant, not taking into account any external effects, then people think that this choice is not socially optimal. And I agree to that to a certain extent. I agree to that argument. But the thing is, the policy that is in place is very blunt and is basically the same policies pretty much everywhere, which means that the needs for parking are not the same across space. So having this blunt policy without taking into account, for example, the needs for parking or the existing parking, for example, off street, can force basically developers to end up like providing excessive parking in certain areas. And that's where the problem may emerge. So we're going to actually discuss that as well here in this paper.
May I ask one question? I mean, here it looks like you focus on the shadow costs, but at the same time, just like any other transportation infrastructure, they, incur costs, but they also bring a lot of benefits. For parking, the same thing, right? I mean, even though for the, the more congested or with higher, land price, does not mean that we put the parking lot far away, that will lead to the lost time and all kinds of safety, all kinds of costs. I'm wondering Would that be
We're not
part
gonna,
of the equation?
no. And you guys will see how we measure a shadow cost of the regulation in this paper. But just to give you a preview, what we do here is not the social shadow cost of the regulation.
Mhm.
This is only the net private shadow cost of the regulation.
So no benefits analysis.
No, we do have the benefit. We're gonna, because our shadow cost is a net cost.
Okay, net.
So you're gonna see, because we have a theoretical model that actually develops the measure that then we calculate with our estimates. And you're gonna notice that the shadow cost is actually a net cost. So it's gonna be this gap. So you guys, just a preview, it's gonna be this gap between the cost of providing a parking space minus the marginal value of parking. So the gain is there. But it's from the private perspective. So it's not a social,
No social.
yes, it's not a social shadow cost. Okay, so I think everybody in this room is probably aware of what we mean by minimum parking requirements. You know, they're not just typical of the United States. A lot of countries worldwide, you have these parking standards, and basically what the policy requires is for developers to provide for each type of land use a minimum number of off-street parking spaces per square foot of new construction, and that's typically the rule for the non-residential sector, or per dwelling unit, and typically that's the rule for the residential sector. So what we're going to be doing is we're going to be using data for office. So we're going to be focusing only on the non-residential sector. And this is one of the contributions of the paper. Because, and I'll get back to that point later on, you know, there are several papers that have measured, right, the level of stringency of land use regulations. But all these papers that have done that, they focus on the residential market. To our knowledge, this is the first paper that actually tries to examine the variability of the shadow costs in the non-residential sector. So what we're going to be doing is we're going to be using data from CoStar on office properties in Los Angeles County, and we're going to use transaction data from 1997 through 2005. And our data set is going to have not only the transaction prices, but it's also going to have several structural characteristics, in particular, the building area, the land area, and the number of parking spaces. But also it's going to have some location characteristics, like, for example, the zip code, the geographic zone, the latitude, and the longitude. All of this is part of our data set. Now, there is, however, one thing that we'll need to address, and I'll explain that in a minute, about the number of parking spaces, because we know that, you know, developers supply very different types of parking, right? Parking can be at surface, can be underground, can be on structures below ground, right? And therefore, the cost of providing these different types of parking is not going to be the same, right? But the problem is when we look at our data, we know how many parking spaces our office buildings have. We just don't know the type. So the CoStar data does not tell us the type. So we had to do something, right, to identify the type of parking that is provided with our office places. And I'm going to explain to you how we did it, okay? But I just wanted to give you a heads up about that. So this is actually the summary statistics of key variables for our office properties. We have a total of 2,571 offices that are part of our data set. As I said, we have data on the property land area, parking area, building floor area, the era in which the property was actually built. But as I said, one of the problems that we had to deal with is, since we want to measure the shadow cost of the regulation, and the shadow cost is going to be measured by this wedge between the cost of supplying a parking space and the marginal value of the parking space. And because our offices do not provide only one type of parking, we had to kind of track the different types of parking that are associated with our office property. So what we did was we developed an algorithm that would actually identify surface parking. And we obtain actually 100% accuracy for what the algorithm classifies as parking under a surface structure, okay? And when we classify all the parking in our data set that is at surface with this algorithm, 83% of our parking is at surface. So that means that 70% of the parking we have in the data set is something else, but we cannot use the algorithm to identify. So the way we did it was manually. And for that, we basically use Google Earth, Google Street View. And then once we have classified the whole thing, we just did some ground truth tracking just to make sure that we were not being misguided by Google Earth and Google Street View.
So surface mean, sorry.
Oh, I'll probably.
I'll go like this?
Yeah.
I start there.
So there are three types of parking: surface, structural, and
We have four.
subterranean.
We
Okay.
have 4 in our data set.
Surface.
We're gonna have 4. We have surface parking, we have underground,
Okay.
we have semi-underground, and then we have below ground, so just structural parking above, so below surface.
And I have one other question, if I could. I know CoStar is incredible. They set the gold standard for data, and they're quite pricey. Did they cooperate with you? Did you have to purchase the data?
My co-author purchased, and I don't ask questions. I just say I'm super happy with the data.
It's incredible.
He got the deal with CoStar, yes, and it was pricey.
Yes.
It used to be free.
Well, CoStar-
I don't know, we pay for, we
No, I know,
know,
but that's
we
not
pay
more.
for it. So, yeah,
So is this algorithm using some sort of AI to?
No
raise the
AI.
image, or?
no, actually, this was one of my PhD students who developed the algorithm, but there was no AI when he did that.
Manual work?
ChatGPT was not, around when he did that. But we were very happy with the fact that he was able to develop the algorithm to classify. And again, we did several checks to just make sure that everything was working fine, and especially for those other parking types that we couldn't do it with the algorithm. I remember driving to some of the properties just to make sure, not just me, I also hired some students to help me out. But we had to do that just to make sure that we felt confident about the classification.
Was it a sort of a density? If you had enough land for surface parking, did you look at the size of the building and the stories, and then if you had enough land for surface parking, it's assumed that it's surface?
Yes, we actually did that because we knew the
Footprint.
yes, the footprint. And that's how he actually came out with the idea of surface parking.
Makes sense.
Yes.
Yeah.
Okay, so based on that algorithm, so remember we have 2,571 offices in our data sets. And based on the algorithm, 83% of those office properties have surface parking. Okay, so parking at surface, right? Parking lots. Then 30% have semi-underground, 2% have multi-structural, and then 2% again are underground. Now you may ask, how come like underground is so low? It's because most of our office properties are actually very low rise. So I just wanted to also make that to explain why we observe so much surface parking in our data set. And these green dots are basically the location of all our offices in Los Angeles County. And I just highlighted here an important part that I will be discussing later on when I present you the results of the paper. And this is basically the CBD of the region, right? This is so before we would think of the CBD as the downtown area, right? Downtown Los Angeles, which is this square. But these days, right, the downtown area is more extensive, right? And includes also the Wilshire, Santa Monica corridor. So you can think of the downtown or the central area has these two areas, okay? And this is going to be relevant because you're going to see that the shadow cost in this area is really different from the shadow cost of the others. But I think everybody in this room probably is familiar with the geography. Okay, great. So how are you going to measure, how we are going to measure basically the shadow costs, right? And as I said, this is not the first paper measuring the stringency of a land use policy. For example, when we look at the literature, we have the paper by Glazer and al. 2005 that actually measured the shadow costs of residential land uses, and he calculates this regulatory tax has this wedge between the market price of a housing unit and the marginal cost of that unit. And his argument to use this has the measure for the land use stringency is that in very competitive markets, what we should observe is that the price should be equal to the cost. So if we have a gap, it's because of the regulation. So that's his argument to measure the stringency like that. And this measure has been adopted in several studies already, all of them focusing on the residential market in different parts of the world, but all based on the residential parking. This paper is for New York, so in particular Manhattan. Then we have the paper by Jen Bruckner and co-authors from 2017. And what they do is that they came up with a new measure for the stringency of a land use regulation. They also focus on the residential market, and they're going to apply this to Chinese cities. And the way they do it is they basically calculate or basically estimate, if you want, the elasticity of the land price with respect to the far limit. So the far limit would be the land use regulation. And the motivation that they use to use this metric to measure the land use stringency is that, if you allow developers to build at higher densities, right? So this means that they can actually provide more development, then the parcel of land is more profitable, right? And this obviously going to increase the value of developed land, right? So if you put a cap, then you're basically removing all of this and your land is going to lose a value. So what they find in their paper is that this elasticity is actually positive. And this is a measure that has been also adopted in other papers with applications in the US. This paper here, Moon 2019, is an application to Manhattan. And then we have again a follow-up paper from Bruckner and his co-author from 2020, where he applies the method for other US cities. In our paper, we're gonna do a slightly different way of calculating the shadow costs. Actually, we're going to use the Lagrange multiplier of the developer's maximization problem as the metric, okay, to measure this stringency of the land use regulation, in particular parking requirements. And the way we interpret this shadow cost, right, this lambda that is associated with the developer's problem, is that it actually represents the profit loss because of the regulation being binding. So how do we measure this? This is actually derived in an analytical model. This is basically measured, since this is a cost, by this gap between the cost of providing a parking space and the marginal value of that parking space. And we expect the shadow cost measured this way to be a positive number, okay? Now, how are we going to measure this first component of our shadow cost, right? The cost of providing a parking space. Well, it will depend on the type of parking that we are talking about. So for example, if I'm talking about underground parking, right? The way we're going to measure that cost is just the construction costs below. We're not going to be factoring in the calculation, the land cost, because basically you're providing parking underneath, right, the building. On the other hand, if I have surface parking, I will need to account for two types of costs. The capital cost, right, associated with the construction of the surface parking, but also the land cost, because now I need land to provide 1 unit of parking, right? So this part here will be different depending on the type of parking that we're talking about. And then we have the market value of a parking space, right? And we need to get that information as well. So how are we going to do that? We need to estimate all these components. Okay, and I will explain next how we estimate these values so that at the end we can calculate the shadow cost for each of our office properties. Yes.
Where's the Lagrange multiplier in the shadow cost? Is that in the construction and land cost?
The shadow cost?
Well, where is the Lagrange multiplier in the shadow cost?
This is the lambda, and I'll show you in a minute.
The whole thing is the lambda.
This is the whole lambda, yes. And I'll show you in a minute that result.
All
It
right.
comes from the analytical model. But the lambda, the Lagrange multiplier, is actually this gap. This comes directly from the analytical model. Okay, now, and one thing that is kind of interesting about the Lagrange multiplier method as a way to measure the shadow cost of a land use policy is that you can apply this method, to be honest, to any other land use regulation that is binding, including FAR limits or building heights or even inclusionary zoning, because the logic will apply exactly the same way. Now, there is, however, a paper that I'd like just to refer because it's a paper that is somehow related with our own work. The difference is that they focus on the residential market. And as I mentioned earlier, I focus on the non-residential market. And it's the Sunding and Swoboda paper from 2010. And what they do in that paper is they actually calculate the shadow cost of housing regulation measured by the wedge. So this gap between the price of housing and the value of the structure and land. So it's a measure very similar to ours, right? In the Inland Empire in Southern California, so right next to us. And what they show in that paper is that this shadow cost for the residential market in this area actually varies over space. But we are going to be testing something similar for the non-residential market. And in particular, we're going to be doing two things that they did not do. The first thing is we're going to assess whether the private shadow cost, and again, I emphasize the private shadow cost, no social cost in this paper, of minimum parking requirements to developers is actually greater in dense, high-value areas, right? Because that is to be expected. But one thing is what we expect, and another thing is let's just measure if this is actually the case. And the second thing is we'd like to know how binding, and by binding we mean how costly is this policy to developers. And that's when we're going to compare the shadow cost of this regulation with the construction cost of the building to understand by how much would this regulation increase construction costs. Okay, so how do we do this? As I said, we have a methodology that can be separated in two parts. The first part is we develop an analytical model. And what an analytical model is going to be doing for us, and I'm not going to go with all the details, you guys can find those in the paper. But basically what we do, we develop an analytical model that gives us all the hypotheses that we want to test of the private net cost of the minimum parking requirements for a developer that is located at the CBD and a developer that is located at in the suburbs. So let me just describe what we do. We have two separate models inside of our analytical section. One basically addresses the problem of a developer that is located in a central area, like a CBD. right? And the goal of this developer in this particular area of the urban area is to maximize, basically, maximize the profit per acre, right? By choosing two things. Structural density, so how high do you want to build, but also the number of parking spaces. But because this is a developer located at the CBD, what we did was we used prior knowledge from a paper that I have written with Jen in 2017, which is a theoretical paper that has basically shown what is the likely parking technology that developers will use in different parts of an urban area. And the paper shows that developers located at the CBD will be providing underground parking as opposed to, for example, surface parking, because land is very expensive, right? In the downtown areas, right? On the other hand, developers located in suburban areas will provide or comply with minimum parking requirements by doing surface parking, just because land is a lot less expensive than in the downtown area. So it pays off to actually provide parking at surface. So based on that paper, right, we assume, we don't prove, we assume based on that paper that a developer in the downtown area will choose not only structural density, so how high to build, but also the number of underground parking spaces. And by doing that, this is going to be our expression that represents the profit per acre of covered land. It's basically the benefits that you have. So this is basically the capitalization of your parking into the value of your building, right? Minus the costs that you have. The cost is the cost of constructing the building, okay? Minus the cost of your lands, minus the cost of providing the underground parking. And as you can see, the cost of providing underground parking does not involve the cost of land, only involves the cost of actually building, right? The underground parking below the building, right? And the developer is going to maximize this function here subject to the regulatory constraint. So this is the constraint that requires that and when we solve this maximization problem, we're going to see that we're going to have three conditions that needs to be satisfied. Now, it is true that we can always conceive the situation where the land use regulation is not binding, right? But that is not interesting because we want to understand the shadow cost of the regulation, and that implies that the regulation needs to be binding. So we constrain our analysis to the case where minimum parking requirements are a binding constraint to the developer. So what does that mean? It means that if it's binding, the number of underground parking that has to be provided by this developer is minimum amount. So that's what the first condition is telling you. The second condition is telling you that because I'm being forced to provide more than what I would like to, right, I'm going to incur a cost. And that is represented by the Lagrange multiplier, which is going to be positive, right? And is measured by this gap between the cost of providing underground parking and the value of that underground parking, right? And it's basically our measure of the shadow cost. This is what we're going to be calculating. So we need to estimate the parking value, and we need to estimate the cost of providing a parking underground so that we can calculate this lambda, right? And then we have a third condition, because I just said that another variable that is part of the decision process of this developer is how tall should be the building, right? The structural density. And what is interesting to see here is that the developer should be picking an optimal amount of structural density such that the benefit, right, of a marginal change in your structural density equals the marginal cost of that additional density, right? But there is this new component here that is not going to be zero. It's going to be actually positive, right? Whenever your minimum parking requirement is a binding constraint. So in a way, minimum parking requirements also function has, and this is very clear from this component, has an implicit tax on density. Okay, so basically developers are gonna build buildings at lower density than what they would like because of this implicit tax that is being imposed by the minimum parking requirement. If this was not binding, this lambda would be 0, this would vanish. Okay? But we're not gonna be focusing on this. I mean, we could measure this as well, but we're not gonna focus on this. We focus only on the shadow costs associated with the minimum parking requirements, so the lambda. Okay, now for the case of the suburban developer, I'm not gonna, because of the time's sake, I'm not gonna go over the details of the analytical model. I just want to tell you that the problem of the suburban developer is pretty much like this. Where is the difference? It's here. Okay, it's the only difference. And here I will have to account for the land costs associated with a surface parking, and I will have to account also for the capital costs associated with that parking. But the only difference is going to be on this component of the profit function of the developer. So that means that we're gonna also end up with 3 conditions, just like this, right? But again, we're just gonna focus on the one that is related with the shadow cost. And from here, you guys can see already the difference between the cost of providing parking and the ground and at surface. As you can see, you have the component of the land value that we will need to estimate, so that otherwise we cannot calculate this component. And we have also the construction cost associated with this surface parking, which we also need to calculate. Okay, so these 2 are our relevant measures of the shadow cost. Okay, so what do we need? So now that we understand.
Maybe can I ask one question for the earlier
Yes.
slide? So how do you get the parking value, function?
How do I get?
Yeah, the parking value function, because what I'm thinking, the number of parking lots, the value also depends on the demand on the parking. Especially given, availability of many other transportation modes and things, their value can change quite a lot. Now, especially like way more like, the things, some modes, they don't need parking. So I'm wondering,
How do we
is that considered in this parking value function?
Yes, it's right here on the B. So the way you can think is, what is the value of a building, right? It's the rental price that you have, right? Times the size of the building. So you have the rental size per unit of floor area times the total size of the building measured in floor area, right? Now this rental price, right? Capitalize already how much the market values parking in that area. So this B, which is that rental price, is a function of the parking.
And you're gonna estimate that.
So that is
And we're gonna
implicit.
estimate that.
Yeah, implicit, because I'm thinking, now with the, ever changing of the, maybe I'm considering shorter term effects of the, different transportation modes, like transit availability, like those things. So you consider that is already kind of like a perfect market that is already included.
Okay.
How people's choice of transportation modes basically would impact the parking.
This is not modeled here. Here, I just have that the rental price capitalizes, so internalizes already how much that area values parking, right?
Okay.
And building on what you're basically asking me, even though I don't model here, right? But what we would think is, if I have an area that is very well served with public transit, the value that people in that area put for parking is lower, right?
But to get that, I mean, you have data on rents and you're gonna use
Yes,
the data
to
to
estimate
estimate
this.
the parking,
The parking value,
parking
correct.
value.
Okay.
But I just wanted to do the connection with what you were saying, but because we do
Getting more
not.
to the transportation side.
Right, and that's fine. I think it's a good observation. It's just that we don't model travel modes here,
Yeah, right, yeah.
right? And for us, everything gets capitalized in the rental
okay.
price.
But then that is based on the assumption that the market is kind of like perfect, or in a sense, or almost perfect, or people are rational. They know what they are doing. Not like the country, you know, the market is kind of irrational, like, you know.
Sure, there is an assumption of rationality in the sense that people know their preferences,
Yeah.
right? About what they like in terms of transportation, and they clearly have a taste for parking.
Yeah,
Did you use CoStar for your rental data?
We did. Actually, what we're gonna be doing is we're gonna use the transaction prices of the office buildings. Because since we have the characteristics of the office in terms of the amount of parking land and other characteristics, but parking land is the one that is relevant to us. We're gonna use a hedonic approach to actually extract the value of land from these office transaction prices.
Right, but for your office rents per square foot, did you use the rent information that was provided?
It was not rent, we used transaction prices. So I just said that this is rental price, but the way you can think about it is that we have the price,
You
right?
assumed a certain return would be expected at a price and you backed into the income.
Right.
Got it.
And so for us, in our data, so in the analytical model, I can play with these two components, right? But in the data, we don't have these two components. What we have is the overall value that I have here. I cannot separate. I have the overall value. And that is through the office transaction price. So all we have to do is extract from that price the value of parking.
When you say transaction price, you mean the price of the sale price for the building?
Sale price.
That's what you're talking about.
Yes, exactly.
So you took the sale price and you took the particular rate of return that you would expect an investor to want, and then you backed into what the income would be, and then that you were able to determine based on what the income would be, what it would be on a price per unit or price per square foot or. Right?
Now, what we did was because our buildings are a function of several structural characteristics, including the amount of parking area in the building, right? We use a sort of hedonic approach, but it's not the traditional OLS. We also did that, but it's not like that. But it's basically an hedonic approach where we basically look at that price and we decompose the price in the different attributes, right? Being parking land one of them. And our estimates are going to be parking, the parking value per square foot. So it's the parking value per square foot of parking land. So that's how we're going to be measuring parking value. I think once I show you the bricks is probably going to be easier. So one of the things is if we believe that the shadow costs are going to be varying over space, right? We need to have a sort of approach that allows us to do that. And therefore we cannot have an approach that is going to basically estimating global spatial estimates like we typically observe. So how do we handle this? How do we get the estimates for parking and land values that we're going to be used to calculate that lambda? We're going to use what we call a mixed geographical weighted regression, right? And what this approach allows us to do is instead of having a global estimate for parking land and parking value and land values, we're going to be able to estimate parking land and parking values for each property around the space. Okay, so instead of a global, we have local specific parking values and parking and land values. And the reason why we use the mixed geographical weighted regression is because we're going to allow in our estimation that certain coefficients are going to remain constant. And which ones are we going to remain constant? The ones that are associated with the locational attributes. And the reason is because we believe, since our bandwidths are really small, we believe that within that bandwidth, these location attributes like distance to the sea, distance to a freeway, doesn't change much on that such a small bandwidth, right? But we're gonna allow other parameters, so other coefficients to actually vary over space, and those are gonna be associated with the structural characteristics of the buildings. One of the concerns we had was the omitted variable bias is always a problem, right? And the nature of our data does not allow us to use the conventional or the traditional methods like regression discontinuity, or even, for example, an IV approach. So what we did was to use this framework that was developed by Bajari and adopted by Lee in 2013. And basically, this framework is based on rational expectations. And what they do is the following. So under rational expectations, we expect that past sales prices in a given area can actually be a proxy for unobservable local amenities. So what we do is we take this framework and we're going to embed the framework in our mixed geographical weighted regression. How? By basically using this interaction between a pre-period median housing price at the zip code of the property interacted with a quadratic year trend. So here is just a list. I'm gonna just, for the sake of time, I'm not gonna go over this in detail, but this is just a list of the coefficients that we allow to be basically varying. And as you can see, they're all related with the structure of the property. And then we have on the second part, so here we have the coefficients that we assume to be constant, and they're mostly associated with location because our bandwidths are really small. Okay, so what we have here, I have here the results for our mixed geographical weighted regression, okay, with the rational expectations embedded. And the coefficients of interest are going to be the ones on the properly land area, parking area, and in particular, those are the ones that we need. But what we want now is to find the estimates for the parking construction costs. And we're going to use the RS means data to actually calculate the parking construction costs for the different types of parking that we have identified in our data set. Then we're going to be using the historic costs index that are also published by the RS means to basically move forward and backward in time these construction costs. And once we have also the estimates for the parking construction costs, then we have everything we need to calculate those shadow prices. Now, for robustness, and I don't have time to go over all these checks, you guys can see all the checks results in the paper. I just want to highlight that we did additional work. We conducted a real world market test where we collected basically the minimum parking requirements for all the cities that we had in our data set. And then we compared these minimum parking requirements with actually the number of parking spaces that were provided with each office building. So we call this the real world market test. And then we also use only for a subsample of our office properties, those located in Los Angeles, in the city of Los Angeles, IV approach, where we use historical parking requirements that dated from 1946. And the reason why we focus in the city of Los Angeles, because the state is really good, and we were able to actually implement IV in this subsample of our data set. So these were like two of the robustness checks that we have done. And then another thing we have done also just for completeness, and again, for the sake of time, I will not go over this because I just want to give you the main results that we have found for our shadow costs. We also have explored which factors are actually correlated with the shadow cost of the minimum parking requirements. And here we have focus on two, the parcel size and the parcel land value. And finally, we also explore how ILIO mandated parking fees actually compare to our measures of the shadow cost. Why? Because certain cities have in place this other regulation called the ILIO parking fee, where developers have the option of paying a fee to avoid providing the amount of parking. right? So in a way, you can think also of, the in-lieu parking fee as another way to measure, right, the cost of the regulation. So we have used this also as a secondary analysis of our shadow costs. Okay, so here are the results. So let me tell you what are the results. So as I said, we have estimated the parking land and the parking value using the mixed geographical weighted regression. We also have estimated our construction costs for all the different types of parking that we have in our data set, and we use the RS means costs that they publish for garages. And once we had that, we basically calculate our minimum parking required shadow costs. We have several specifications, but our favorite is actually the specification number 5. So all our calculations are going to be measured, are going to be done based on the results that we have from our specification number 5, which is a specification that also controls for basic building characteristics, pre-period sales price trend. We also add extended building characteristics, basic geographic characteristics, and zoning and local amenities. So this is our favorite specification. And based on our favorite specification, the average minimum parking requirement shadow cost is $26 per square foot. The problem is this masks variability, right? So our next question is, let's estimate, right, the percentiles for our minimum parking requirement costs. And here, when we calculate this, we can see that there are very large difference in the minimum parking requirement costs per square foot across our office properties. So for example, at the 75th percentile of the minimum parking requirement costs, we have a shadow cost of $37 per square footage. If we measure the 95th percentile of the minimum parking requirement cost, we have a $99 per square footage. So this means that the top 5% of the properties in our data set have a shadow cost, right? That is more than 2.5 times the cost of a property located, right, in the 75th percentile. So this means our minimum parking requirement costs are quite skewed, and the burden falls in a small set of the properties. Which ones? Then what we did was, let's assess the shadow costs across space to understand where is this burden, right? And we can see that clearly the burden is located where? In central areas, that's the Wilshire, right? And Santa Monica corridor right here, right? Right here, everybody can identify the orange and the red, and the downtown Los Angeles. And there's some hot spots, but it's mostly here, right? And this is not to be surprising, because this is an area that is highly dense and land values are very expensive here. So the cost of complying with minimum parking requirements in these areas is quite high, as opposed to other areas that are more on the outskirts where land is not so expensive. Okay, so to wrap up, to conclude.
So can I ask a question?
Yes.
So I mean, the plain English explanation is that, say for your $26 thing, that the $26 is saying that a parking space, an extra parking space generates construction costs per square foot that are $26 above the value of the parking space.
Yes, and that's, I skipped because of time, but I have this. This is kind of nice. So give me just 1 minute.
So the regulation is making people produce things that the market doesn't value.
Exactly. It's exactly like that. And I have this, I kind of skip it, but this is where we compare the shadow costs with the construction costs, so that you guys can see that the shadow costs really inflate the construction costs. I'm not going to go over this, like all the calculations again, you guys can see it, but I can tell you that in our office properties in our data set are required to provide 1 to 2 parking spaces. Okay, per 500 square footage of new development. So when we do the calculations, we see that the shadow cost in this scenario of just one mandated parking space is $50. And then when we compare the $50 with the base construction cost of the building, which is $160, this represents a 31%. If I use two, it's just double. It's gonna be double, right? So as you can see, the cost is big enough to actually affect developers' decisions, right? And on top of this, like Jen was saying, right, this shadow cost indicates that these developers are actually providing something that is more costly than what the market actually values. Okay? So in conclusion, to wrap up my seminar, what did we find? First, minimum parking requirements find more in dense areas where the value of land is very high. And that was very clear from the map that I just showed you last, right? And these are the central areas, right? The Wilshire, Santa Monica corridor in downtown LA, and also the coastal areas. In these areas, the market value of parking tends to be lower, right, than the cost of providing that parking, right? And that goes along with the comment that Jen just did. And we also show in the paper, I didn't have time to share that with you, but in the paper we show that smaller parcels have more binding minimum parking requirements. And this should also be intuitive, right? If I impose that you need to have, let's say, 2 parking spaces on a parcel that is super small, the cost of complying with the regulation is a lot bigger, right? And the constraint on the development is going to be a lot higher, right? And then we also saw in our analysis that a large proportion of the properties have minimum parking requirements that are large enough to influence developers' decisions. So it's not surprising that, you know, these minimum parking requirements, because of the cost that they impose on the cost of development projects, that they end up like shifting, you know, some of these projects to areas where it's easier to comply with the parking regulation. And obviously this has implications for downtown areas that need agglomeration economies to boom, right? Because if you shift, you know, that development to other areas where it's easier to comply with the regulation, you're also compromising agglomeration economies. We don't measure that, but we can discuss that based on our results. So that's a preview of our paper, lots of details in the paper, please have a look, okay? I've already shared the paper. If you have any questions after you go over, talk to me about it. I'm always happy to talk about parking, okay? So that's it, I don't know, any more questions? I think we're good, I just 1 minute, 1 minute.
I just want.
1 minute after.
Here's a 1 minute question. Does your data include any data on the price of parking? Because some of these
No.
CBD things
No.
do charge for parking.
No, we don't have price on parking. But I did collect a bunch of parking prices, not for this project, but for another project, because I'm kind of interested in understanding how, you know, commercial parking facilities compete in space. So I was collecting all this parking for LA County. Took a while, lots of students helping.
So related to David's question, I mean, what are the policy suggestions based on study? Do you suggest to charge higher?
No, remove parking. Minimum parking requirements, just get rid of them. And that's what actually a lot of cities are currently doing. They're
So,
already like eliminating minimum parking requirement.
so you know, based on study, then people will, you know, in those core area, then the builders not interested in having any parking.
No, developers will provide parking if
But
the
then
market values.
But would be way below the.
But it would be
MGR.
below than what the market, than what the regulation is requiring. There's going to be
I know.
areas where there is a lot of demand for parking, and therefore, obviously, the developers can capitalize on that and will provide everything. But there's other areas, especially close to public transit, right, where that need is not so big, right? And that needs to be taken into account when you decide how many parking spaces.
Yeah, but you know,
Provide.
I know that area a little bit because there's a lot of emphasis, general consulates on, in that area. And, when I go there to get visas. And it's really hard to find any, parking space, there. So I see a lot of social value for, this NPR,
Right.
or I mean, or on other way, in the other direction, if you eliminate NPR and then they are building way fewer parking spaces, then maybe the consulates will move out of that area. You see what I mean? I see there will be other secondary or, those effects. Then they will hurt their, rent.
I agree with
prices.
you that developers only take into account private costs and private benefits.
Yeah.
Right? So I agree that in certain areas, maybe there is too little parking, right? But the problem with minimum parking requirements is that these numbers come from the sky, right? There is no connection, right, to the market, right? And you should be linking exactly to what you're saying, right? That is there any off-street parking available that people can use?
Yeah.
Then there's no need for on-site parking. Is there public transit, in the region that can serve that area? Then in that case, I don't need so much parking, right?
Exactly.
So, but this means that the policy needs to be done, take into account the local characteristics, but the minimum parking cars are
I
not set
agree
like
with
that.
you, totally agree.
They just put the same rule everywhere, right? And then it becomes very distortionary in certain areas, especially the ones that are very dense and high value.
But my point that this distortion might be justified in a sense, because they do have really high demand on parking, may not be by the residents, not the workers there, however, a lot of visitors. For example, the visa interviews and a lot of visitors. I don't know. I mean, whether that's already captured in the prior. I mean, the benefit function already. You see what I mean? So this is kind of like a social aspect.
I went to a
You should.
consulate a while back in exactly the Wilshire corridor.
Yeah,
And the parking rate in the underground thing was $20.
I don't know, but definitely charge. I mean,
But
I mean, it's always hard to find a parking space. So, that's my point.
Because you didn't want to wait
maybe-
$20.
For those specific areas compared with other areas, the social benefits are even more important.
But we also need,
When we do this study.
to take into account one thing. These are on-site parking, right? This is parking associated with the office building, right? But there's also commercial parking, right?
Yeah,
So if there is a lot of commercial parking out there,
okay.
maybe there is no need to be supplying all this much parking on site. Right?
Yeah, a
So
lot.
again, it's necessary to have a look, right, at the characteristics of the area. Right? So for example, I'm from Portugal. And I'm from Lisbon in particular. And there's a huge shortage of parking everywhere in the city for different reasons.
Yeah.
But every single time I go out in Lisbon, I always find parking. Where? Not at the curb, but on commercial parking facilities, all of them underground the city, all of them. There's no surface parking in Lisbon. Price is too high, everything is provided underground. Is it expensive? It is expensive,
Yeah.
but it's not $20, but it is expensive. But then, you know what I see? I see office commercial, I see commercial parking facilities almost empty underground where you can pay $5, let's say for 1 hour, $5, right? So it's not that much, right? And then I see a bunch of people cruising for parking, looking for a parking at the curb. And then I see triple parallel parking. Super common in Lisbon. Why? Because people don't want to pay to park on the commercial parking facility, pay $5. And then they go to the restaurant and they pay $80 for the meal, right?
Yeah.
But no $5 for parking, because parking has to be free. So we have also this problem, right? So sometimes it's not that there is a shortage of parking. People want parking that is free. I don't want to pay for it, right? And I just cruise 20 times looking for a parking space and then I give up and then no, I don't do that. I behave, okay? I pay my parking, right? But people cruise and then they park like triple, right? Parallel parking, and that's it. So we also have this problem, right?
So, I mean, this actually leads to a bigger discussion. I mean, regarding, people, why, I kind of, understand why some people want to save, several bucks, by cruising. Because, maybe, the value of time is not that high, so this actually gets to kind of like equity issue. Do you see this as kind of make it more equitable or less equitable by reducing or just removing, MPI? So,
In European cities, that argument is not valid because people cruise because simply they don't want to pay for parking.
some people, I guess,
It's just,
psychological.
it's just a cultural thing,
Okay.
right? And they arrive late everywhere.
Southern.
Yes, okay, I'm gonna restate what I
That's
said. In
interesting.
Southern Europe, yes, it's typical.
Let's not fight economic.
There's no economics here. This is just people's behavior. They simply think parking should be free. I'll cruise 20 times, I'll arrive late and it's acceptable and it's all good. We don't see this where in the United States, right? I don't
It's
see,
more rational.
no, fines are higher.
I think it's because the value of time as far as being late
Yeah.
in certain cultures is very low. Like
Yes.
people don't hold you accountable.
Exactly.
That's a penalty.
And fines, I think you guys are forgetting something. Fines for not parking correctly in the US are really implemented and they are high, so people kind of watch out. In Europe, you get the fine and you say, we'll see next year. Because no one pays. I mean, I think it's kind of sad when we think about it. That's why it's so messy in certain parts of Europe. Like the parking situation. And when they say, we need to have more parking, no, we don't need to have more parking. We need to have people parking on empty spaces, and the ground and pay $5. That's what we need.
Maybe that's why they are happier.
Yeah, we're happy because we have the sun. We have good weather. That's why we're happy people in the southern parts. But anyway, any other questions?
Yes, I'm curious, so I 100% agree with your ideas. But do you think that there are some sort of, because I think that this is particularly important in places like Los Angeles where there are a lot of like high building restrictions. Right?
Yes.
Do you think that this new bill passed by the state of California actually that will allow building higher buildings close to the
Public transit?
yeah, so I think that this bill is going to make this shadow cost the way lower for
Yes,
the-
and that is supposed to stimulate more new construction at higher densities.
We'll
and
see
I-
it, but yeah.
Now, there's some certain projects where we can see that already.
Mhm.
And I don't know if you guys have gone, I don't know, recently to downtown Los Angeles. If you remember downtown Los Angeles, I would say like 10 years ago or 8, there were a lot of empty spaces in the downtown area. And over the last 8 years, more or less, there's tons of construction. So parking spaces that used to be there no longer exist because now they're just, increasing, they're just building.
No, it's incredible how this
and the
has
reason-
shaped the cities in
And the
America.
reason is
It's
because
crazy.
there has been a change in the parking requirements in certain pockets in LA. And I think that has stimulated also, right, the construction of all these new buildings because that land was clearly speculation. They were just waiting for the right opportunity to start building. So now you see all this new construction going on there.
That's mostly residential.
Yes, mostly residential, correct. Yes.
Yeah.
Any other questions? No? Okay, thank you for having me.